Okay, so write an equation in terms of sine and cosine using this graph. So the things you need to start with are going to be the A value, the B value, the C value, and eventually we're going to have a D value here at the end. But right now, just those three. To find A, you can look at the graph to find A. But ultimately, A is going to always equal to the max subtract the min divided by 2. So if I looked at this graph, my max is here. So that's at the number 1. And then my minimum is here. And that's at the number -1. So if that's the case, my A value is going to be 1 subtract -1 divided by 2. So that's going to be 1 plus 1 over 2. Just 2 over 2, which is 1. So no, A has to be 1. And that's the first thing we have. The next thing we have is the B value. The B value is going to be, well, we know the period is equal to 2 pi divided by B. So since we know the period is 2 pi divided by B, we can choose a place to start this graph. And if I look at this graph, let's say it was sine, so because we're looking at sine, a good place to start with sine may be right here, because afterwards it goes up, comes back down through, and finishes there. So that would be a good one period of the sine curve. So if this is the starting place, this is what the period ends at for one period. We can find out how long this segment is. Again, I tell my students to start at the right and always subtract backwards. Meaning that on the right, we have 7 pi over 3. And I'll subtract whatever that number is. It's a positive pi over 3. So 7 pi over 3 subtract pi over 3. Since they both have the same denominators, you can subtract across the top. That'll leave you with 6 pi over 3, which reduces to be 2 pi. So my period of this curve is 2 pi. So if that's the case, I know since the period is 2 pi over B, I know it should be the formula of the period should equal to the actual period. And it's really nice because you probably just know what B has to be 1, because whatever 2 pi over B has to equal 2 pi, well, B would have to be 1. Well, if you didn't know, you would put 2 pi over 1 and you cross multiply. So if you didn't know any better, you would put that over 1 and you multiply here, multiply there. So B times 2 pi has equal to 1 times 2 pi. Well, 1 times 2 pi is just 2 pi. And B times 2 pi is just that. So to finish solving for B, you divide both sides by 2 pi. So that you see that these cancel. So B has equal to 2 pi divided by 2 pi, which you know is 1. So I know that B has to be 1. So the last thing there is to find is the C value. And the C value is negative C over B. We write that equals to the starting point. So if you go back and look at it again, the starting point was right here, pi over 3. So since pi over 3 is the C value, that's what my starting point is. So if you remember, starting point equals to negative C over B. So since my starting point is pi over 3 equals negative C over B. We already know the B value is 1, so I'm going to write negative C over 1 equals a pi over 3. So if that's the case, I know that negative C equals a pi over 3. And if finish solving that, divide both sides by -1, you're going to get C as negative pi over 3. So now I know A, B, and C. And if that's the case, I can go about writing the equation. So I'll start here. My A value is 1. So it's going to be a 1 here. Times sine. The B value is also a 1. 1x. Subtract the C value. It's negative pi over 3. So if that's the case, we have a double negative here, which means it's really positive. So it should be 1 sine, 1x is just x plus pi over 3. So that's an equation for that curve. You can come up with lots of equations for that curve. This is just one of them. Technically, you need y equals in there. So that is better written as y equals all of that. So again, depends on who is doing it, you have a different equation. Because if someone else came behind you and they chose to start here for sine, they wouldn't be wrong to do that. And they would come up with an equation that looks different from yours. And if someone else came along and they started someplace else for sine, for example, they started here, they could start here, go down, and come back up. They can come up with an equation for sine, so that would be a negative sine, because it started going downward first. So you can come up with multiple equations for the exact same line, but all, if you graph on the calculator, all represent this exact same equation. So just because it looks different from yours, doesn't mean it's wrong. It just means they chose to write it a different way. So that's one with sine. Let's look at one with cosine. So in this one, we're going to write an equation in terms of cosine. And A value is still there. The B value is not, it's just like it was at first. Subtract C. You have a new letter in this one though. And it could be with any of them, sine or cosine. The D value. This D value represents the vertical shift. So we talked already about horizontal shifts. We talked about how this A value gives us an amplitude that ultimately stretches the graph, makes it taller, shorter. And the C value gives us a shift to the left or right, a horizontal shift. Well, this D value has never been added outside the parentheses, this being parentheses. This number been added out here will represent your vertical shift in the graph. So let's get started with this one. Suppose we start with cosine. Cosine would represent this, again, this symbol of a Texas Longhorn or a U kind of with little hooks on the end here. Given that, we have a starting place. In this problem, my starting place is right here. And it ends right here, one period. So, I know enough to get started. And this one may be easier to find the D value first. The D value is basically this line right here. Whatever that line is, represents the middle of the curve, that's your D value. That line goes through, it's counting up by 1, 2, and that's a 3. So I know it's counting by 1s. So that line represents 1. So I know my D value is 1. So after I know D, I can then go about finding amplitude. My amplitude is still the max subtract min divided by 2. Here, my maximum is here at 3. My minimum is here, and that number is at -1. So that's my minimum, it's at -1. So I will wind up having 3 subtract -1 divided by 2. Well, we know that means 3 plus 1 divided by 2, which is 4 over 2, which is 2. So A is 2 in this problem. So that basically means that I went up 2, from the middle line. If you count it, it went up 2 spaces. I went down 2 from the middle line, and you do 1, and that's 2. So I know A. Next thing is B. You don't know B until you know the period. So you go about finding the period, just like we did last time, by finding how far this is. It's taking this number, subtracting backwards. So it's going to be pi, subtract negative pi. So pi subtract negative pi, so it means pi plus pi. 1 pi plus another pi is 2 pi's. So that period is also 2 pi. So to find B, again, it's going to be the period. It's equal to 2 pi over B. So 2 pi over B equals 2 pi. We just did it a while ago. We should know B now is 1. And the last thing we need is the C value. And that comes from the starting point. So since I started here, I started around the curve, the starting point's right there at negative pi. So my start is negative C over B, which equals to the number we decided was negative pi. So since B is 1, is negative C over B, that's equal to negative pi. Again, B is 1, so we'll call it 1. Negative C over 1. So I want to finish solving that. I put over 1 as well, and cross multiply. 1 times pi and 1 times C. So basically, negative C is equal to negative pi. You divide both of those by negative 1. And you find the C equals pi. So I know A, I know B, and I know D. So I can begin writing an equation. My equation for this curve should be y equals A is 2. So it's going to be 2 cosine. The B value is 1. So it'll be 1x. Subtract. The C value is positive pi. Pi plus, because we have a new line here that wasn't in any of the problems before today, that has a shift upwards. We have a D value, and that D value is 1. So, and equation for that curve is that. And that's all there is to know about it. At this point, you're welcome to start beginning with the homework. Good luck.